Okay, so this is going to be the part 1 test review. I'm going to go over a few of these because I'm not going to see the need to go over every single one of them. The sub is going to have the key that you're going to end up using to go ahead and verify your solutions, but if you've got a question about the process, this is what this is actually for right here. So if we look at number 1, again, some of you are familiar with FOIL. In the end, we are distributing. We're taking this 2v and multiplying it by 4v, giving me 8v squared. This 2v times 1 gives me a plus 2v. The negative 5 times 4v is negative 20v. And the negative 5 times 1 is negative 5. Well, combine like terms, and we have 8v squared minus 18v minus 5. Okay, so that's what we're doing when we're multiplying a binomial by a binomial. All right, if we come over here to, let's look at number 4 for a second. We'll just kind of mix it up here a little bit. Again, 5m times 7m gives me 35m squared. 5m times 5, 25m. Negative 7 times 7m, negative 49m. Negative 7 times 5, negative 35. So now we have 35m squared. We combine like terms here, gives me a negative 24m minus 35. All right, let's look and see what else we've got. Okay, again, if I've got a binomial multiplied by a trinomial, the same thing happens. It's no different. 3p times 7p squared. Well, 3 times 7 gives me 21. P times p squared gives me p to the third. 3p times 4p gives me 12. P squared. 3p times negative 6, negative 18p. Start with the 2 now. 2 times 7p squared gives me 14. P squared. 2 times 4p gives me 8p. And then the last one, 2 times negative 6, negative 12. Well, now I combine like terms. I don't have any other p to the thirds in this whole line right here. So I'm going to drop this guy. And I get 21 p to the third. Nothing changes. 12p squared plus 14p squared, these are my like terms, gives me 26p squared. And then I have this negative 18p plus 8p gives me negative 10p. And then the minus 12 all by itself. All right, so simplifying radicals. This is actually from chapter 6, but I'm going to put it in the test here because I think that, again, we need to go ahead and keep on working on stuff throughout the school year and reminding ourselves that we're actually fairly good with this stuff. The square root of 48a to the second. Well, let's look at this. We'll split it up. The square root of 48 and the square root of a to the second. Well, let's do 48 for a second. All right. So we have 48. We'll just kind of come over here to the side and we'll see what we've got. Well, 6 and 8. Those are usually pretty common numbers when we talk about 48. We have 3 and 2. We have 4 and 2. And then we have 2 and 2. So these are my prime numbers right here. All right, so we have a 2 times 2 times 2 times 2. That gives me, we'll write it out. 2 times 2 times 2 times 2 times 3. Well, this is a pair of 2's. One moves out. Another pair of 2's. Another one moves out. And the 3 is by itself, so it stays in. So we get 4 square root 3. Now when we look at this a squared, well, a squared is just a times a. So since there's a pair of a's, one of them will move out. And there's nothing left in the square root here. So we combine these, we keep what's out of the square root out of the square root. We have 4a, and then we have this square root 3. Let's look at another example of this. Okay, we'll go to this one right here. So we have the square root of 18, the square root of u, and the square root of b to the third. I'm sorry, I'm writing on the tablet right now, and it's not necessarily the most pretty when it comes to writing on this board. But anyways, the square root of 18 simplifies to 3 square root 2. The square root of u, well, we can't do anything with it. And the square root of v to the third, we have 3 v's. One of them moves out, and the other one stays in. Because again, v, v, b, a pair. One moves out, the other one stays in. So what do I have outside of the radical? I have a 3 and a v. Inside, I have a 2, a u, and a v. A 2, a u, and a v. And that's it. That's all we're doing. All right, prime factorization. Easy, easy, easy. We'll go to one that's got a little bit more to it. Let's see here. These were not actually really good ones, but I'll do 16. So 16, we have 4 and 4. And we have 2 and 2, 2 and 2. So when we have 2 times 2 times 2 times 2, that's really just 2 to the 4th. Whereas if I had something like this right here, let's say 30, say 36. Well, we know that's 6 and 6, and that's 2 and 3, and that's 2 and 3. So again, I have 2 times 2 times 3 times 3. Well, that becomes 2 squared times 3 squared. And I want your answers in exponents. All right, that's the prime factorization. All right, when we look at what is my greatest common factor of each one of these numbers? Well, if I look at 44, the factors of 44, I have 1, 2, 4, 11, 22, and 44. 14, we have 1, 2, 7, and 14. What's my largest common factor? Well, it's 2. Okay? But all of a sudden we get to putting a variable in there. Let's look at this one right here. And now I have to ask, okay, what's my largest factor of 48 and 24? Let's look at the numbers first. Well, the largest factor here is 24. Y and no y, no y. X and x to the third, well, I'm picking the one with the lower exponent. That's it. We're not looking to see what we have left because you're not factoring by greatest common factor. We're just looking to identify the greatest common factor. We'll do the last one here. The GCF of 39 and 30 is 3. M and M squared is just going to be M. N and N, well, we'll factor out the N. And that's it. All right, and then again, like I said, not going to go through the rest of them. The answers will be on the answer key that the sub has, so you can go ahead and check with him. And if you have any questions, my best guess is to go ahead and come back to this, look at the process again, look at your homework, look at any quizzes you've got, and refer back to those.